So this is 2025 paper 2 question 2, and we're given the equation of a circle and asked to write the center and the radius. So if you go to the formula and tables booklet, page 19, you have the equation for a circle here where hk is the center, but you can see we have x minus h and x minus k, so we need to make our equation up here kind of look like that. So we can say, instead of saying, well, we can keep x minus 4 squared, that's fine, but then we can say y minus minus 2 squared, because then it's in the form y minus k equals, and instead of writing 45, I'm going to write it as the square root of 45 squared, because then we have the same form as the equation boxed in red, and then we can just read off h must be equal to 4, k is equal to minus 2, and the radius is the square root of 45. So as they asked, then the center will be hk, so that's 4 minus 2, and the radius is the square root of 45, or if you want, you can write that as square root of 9 times 5, which is 3 times the square root of 5. Either of those are good. So then we're told to find the equation of the tangent at this point, and we're told to kind of write it in form y equals mx plus c. So I've done a rough sketch here, so we know the center is 4 minus 2, and then 3 root 5, it's like a little bit bigger than 6, so the radius is just a bit bigger than 6. Let's just say roughly here is the point minus 2 minus 5. So basically, to get the equation of a line, we need to know the slope, and we need to know a point on the line. So we know a point on the line, because this is the point. We need to figure out what the slope is. Now, there's a few different ways of doing it. One way, you could use implicit differentiation on the equation of the circle, but some people will probably find that confusing. I think the thing that most people would be most comfortable with is we know these 2 points here, right? So we can find the slope between these 2 points, and then we can find the perpendicular slope, and that'll give us the slope that's perpendicular to the radius, and obviously the slope that's perpendicular to the radius is tangent to the circle. So yeah, let's find the slope between these 2 points. So if you go to the coordinate geometry page, you'll find that the slope is y2 minus y1 over x2 minus x1. So we can say, we could just call this one x1, y1, call this one x2, y2. So y2 is going to be minus 5, minus y1 is going to be minus 2, be careful for the signs, over, and then we're going to have x2, which is minus 2, minus x1, which is going to be minus, and then 4, because minus positive 4. So on the top, we're going to get minus 5 plus 2, which is minus 3. On the bottom, we're going to get minus 6, so that's going to be a slope of a half, which makes sense that it's positive, because as you can see from the diagram, it is indeed positive. So then the perpendicular slope, we get the negative reciprocal, so we're going to have minus 2 over 1 as the perpendicular slope. So that's going to be the slope of the tangent. Okay, so then we can just fill into one of the other formulae for the slope of a line. So you can fill into y equals mx plus c if you want, but I think most people in their school would learn this equation, y minus y1 equals m times x minus x1. So I'm just going to fill into that one. So again, our point here, it's the point on the circle, not the center. So this is actually now going to be our new x1, y1, which is a little confusing. But minus 2 minus 5 is our point. So we're going to call that x1, y1, and then our slope m is equal to minus 2. So we're going to have y minus y1. So we're going to have y minus 5 equals m, which is minus 2, times x minus x1. And then x1 is minus 2, so don't forget to put in that it's minus 2, because then we're going to get y plus 5 equals minus 2 times x plus 2. So we get that y plus 5 equals minus 2x minus 4, and we want it in the form y equals mx plus c, where m and c are integers. So if you got a fraction, you know that you went wrong somewhere. So we're going to have y equals minus 2x minus 9 as our answer. Then in part B, we're given a new circle, and we're told the line for the tangent, and we're told to find 2 possible values of k. So for the method that I'm going to use, well, the first thing you should always probably do, just because you get partial marks and it usually helps towards the answer anyway, is to find what the center and the radius is. Now for the method that I'm using, we only need to get the center, but it's good to get both anyway. So this time we're going to be using this, where is it? We're going to use this equation of the circle, because that's kind of more similar to what we're working with. So we can kind of rewrite it to look like the equation down there. So we can write x squared plus y squared. Then we can write 2 times 14 times x minus, and then we can say 23, well, 2 times 23, sorry, I need to copy the exact way that it's written down there so I can figure out what g and f are. So I'm going to say plus 2 times minus 23 times y, so you have to be very careful there. I'm going to have plus k equals 0. Plus k equals 0. So our center is going to be the minus g minus f. So clearly here, g is equal to 14, and f is equal to minus 23. So minus g minus f will be minus 14, positive 23 as our center. So if I do a quick sketch of the circle like this, we're told that it's a horizontal line, which you could tell anyway, because it means the y value is equal to k, no matter what the x value is. So if we draw in the tangent, it's a horizontal line. It's either going to be like this, or it's going to be like this. Sorry if I could draw properly, like this. And in both cases, the point of tangency is directly above the center, just because it's a horizontal line, so that's kind of how it works. Perpendicular to horizontal is vertical, so that means that directly underneath the horizontal line is the center. So that means that they have the same x-coordinate, as you can see, because they both lie at the same x-coordinate. So that means that our point here, our point of tangency, is going to be minus 14k, which makes sense because the y value should be k, and as it is, as you can see here. And then we could also have minus 14k down here. They're the two possibilities. So if this is a point on the circle, that means we can sub it into this equation, and it's going to be true. So x squared plus y squared, and in this case, x is going to be minus 14. I'll write this down. X will be minus 14, and y is k, is a point on the circle. So again, we can just sub it into the equation. So we're going to have x squared plus y squared. So that's going to be minus 14 squared plus k squared. And then we have plus 28 times x. So plus 28 times minus 14. And then minus 46 times y. So we'll have minus 46 times k. And then we just have a plus k, and that's equal to 0. And that equation is true, and this is a point on the circle, so this is also going to be true. So we're going to have 196 plus k squared. Then here we'll get minus 392 minus 46k plus k equals 0. And we can simplify, so we're going to have k squared, of course. And then minus 46k plus k will be minus 45k. And then we're going to have minus 196, and that's equal to 0. So you could use the quadratic formula here, or you could notice that we can write 196 as 49 multiplied by 4. Well, it's minus 196, so we can write it as minus 49 multiplied by positive 4. And that obviously adds to give us minus 45, so we can actually factorize this quite nicely. To get k, we're going to get k minus 49 times k plus 4 equals 0. And then what we're going to get is that k is equal to 49, or k is equal to minus 4. And there are our answers.